are recorded, and afterwards you get a copy of the recording. Now, do you have some problems that you can verbalize to me?
Yeah, I have 20 problems.
Okay, let's go through them.
Okay, the first one is solve the system of equations by the addition method.
Okay.
So it's x plus 4y equals 5 over 3x plus 2y equals 25.
All right. When they said do it by the addition method, this is also called elimination.
Okay.
In other words, what I have here is two equations and two unknowns. If you're always allowed to add or subtract equations from one another. In other words, I can add these two equations and it's legitimate, or I could subtract them. The goal is to be able to add these two equations and have one of the variables be eliminated. That's why it's called elimination.
Okay.
Well, if we were to add them as they are now, it would just be 4x plus 6y equal 30. In other words, a variable does not get eliminated. And in order to solve an equation, you've got to get it down to one equation and one variable. In other words, I can't solve that by itself. There's an infinite number of solutions. But when I have two equations and two variables, I can do it. And there's a couple of ways I can do this. Let me choose the easiest way, and I'll show you that in a moment. First of all, let's call this equation 1 and this equation 2. If I multiply equation 1 by minus 3 on the left side, I can do that as long as I also multiply the right side by minus 3. In other words, you can do anything you want to the one side of an equation as long as you do it to the other. And I mean anything.
I have a question. Why would you use -3?
Because it's easier to add equations together than it is subtract. You can do either one. And I could use +3, but I'm going to show you the advantage of using -3 here.
Okay.
Okay. This is going to create a new equation 1, which will look like -3x minus 12y equals minus 15. That's my new equation 1. And you see where that comes from?
Yeah, multiply 3.
It's the same as the original equation 1, except I multiplied both sides by -3.
Right.
Now, I can add equations 1 and 2. And when I add them, the x variable goes away. That's 0x. Well, when I add these two, I get minus 10y. And when I add these two, I get 10. Well, I can now solve that equation because I don't have any x's. Because all I have is a minus 10y equals 10. Well, how do I solve that?
Divide -10 by both sides.
Yeah. So I end up y equals minus 1. Okay. Now, once I've solved for y, I can go back to the original equation and I choose the simplest one there is, which is the original number 1. I substitute minus 1 for y, and I can solve for x. So I have x plus 4 times minus 1, that's what I know y is, equal 5. Now I get 4 equals x equals 9. And so I've solved for both variables. I have x equal 9 and y equal minus 1.
Okay.
And that is the only solution to these two equations. You'll notice that if you plug in those values, y equal minus 1 and x equal 9, this equation is true, and this equation is true. And that's what you have to come up with. In other words, when you solve for a solution, it's got to be true for both equations.
Okay.
Now, let's go back a moment, because you asked a very good question, and that is, why did I multiply by negative 3? Well, let's go back and multiply equation number 1 by positive 3 and see what happens. So I got to multiply it by something, because I've got to be able to eliminate a variable. That's why it's called elimination. Okay. Now this time I replaced equation 1 with the new equation 1, but this time I multiplied by positive 3, not negative 3. Okay.
Okay, where did that 12y come from?
I can still eliminate a variable because I'm allowed to subtract equations by the same rules of mathematics that allowed me to add equations. So if I subtract equation 1 from equation 2, I'm still going to eliminate a variable. I still get 0x. But it's a little harder to subtract than it is to add. In other words, I have 2y minus 12y, which gives me minus 10y. And then I have 25 minus 15, which gives me 10. So I still end up with the same solution. It's just I got it a different way. And I find that about 95% of my students add equations very well. Subtract, not so well. So I really want to set up these equations so that I can add them and eliminate a variable. But the goal is to eliminate a variable. Okay? In other words, if I don't eliminate a variable, let's go back to the original one. Let's say I start with my original two equations and I add them together. That doesn't help. I can't solve it because now I have two variables and only one equation. You cannot come up with a solution when you have more variables than you have equations. You have to have the same number of variables as you have equations. So it doesn't do any good to add these two equations together unless I can eliminate a variable. Well, if I multiply the first equation by minus 3, it produces the same equation, but I've multiplied it by minus 3. And now, if I take these two equations, I can eliminate a variable very easily by adding them together. You are allowed to either add equations or subtract equations. Let's say I gave you these two equations, a plus b equals c, and x plus y equals z. I can add those two equations so that I have a plus b plus x plus y equals c plus z. You can always do that. I can also always subtract equations. So the goal when you have two equations and two unknowns is to manipulate the equations such that you can either add or subtract them and have a variable disappear.
Okay.
Okay? Do you have another one?
Yeah, I have 1/3 x minus y equals 5
Okay.
over x minus 3y equals 15.
Now, this is not really two different equations. Notice that if I number them, equation 2 is exactly the same as equation 1 multiplied by 3.
Mm-hmm.
Well, that means I'm not going to be able to solve it. You have to have two independent equations that are not related. In other words, my second equation cannot just be a multiple of my first equation. And that's what this is. If I tried to solve this the way that I solved the other one, let's multiply the first equation by 3. Well, what does that give me? That gives me x minus 3y equals 15. That's my new equation 1 when I multiply both sides by 3. Well, now I just have two equations that are the same thing. If I subtract one from the other, I get 0 equals 0. I don't have a way of solving for x and y. And so I have what is called an infinite number of solutions. When you have one equation only and two variables, you have an infinite number of solutions. Let's say I said x plus y equals 10. Well, x could be 1, y could be 9. X could be minus 1, y could be 11. X could be minus 2, y could be 12. You can see where I'm going. There's an infinite number of solutions. So you cannot solve one equation with two variables ever. There's always an infinite number of solutions. And it doesn't help to add a second equation that is the same as the first equation. The second equation you gave me was this, which is merely the first equation multiplied by 3. So it's not really a new equation. And that's the key. You can solve two equations with two variables as long as they're different equations. For example, let's say I said x plus y equals 10 and x minus y equals 5. All right?
Mm-hmm.
Those two equations are different. Number 2 is not just a multiple of number 1. They're different, which means I can either add or subtract them. Well, if I add them, I get 2x, and the y's cancel, equals 15. Well, x is equal to 7.5. And once you solve for x, then, if I plug that into there, I get y equal 2.5. So as long as I have two different equations, then I can solve the system of equations. But that's the key. They have to be different. One cannot just be a multiple of the other.
Okay, let's try another one.
Okay.
Negative 25, open parentheses, x minus 5, close parentheses, equals 24y.
Okay.
And underneath that, 5x minus 5y equals negative 24.
All right. Notice the first thing about this is that they're not in the same format. The second one, I got my x and my y on the left side of the equation. I got my number on the right. In the first one, I got x on the left side of the equation and y on the right. So first of all, let's put them both in standard format. So I'm going to take equation number 1 and I'm going to rewrite it after I put it in standard format. Well, that's minus 25x. I go ahead and distribute the minus 25 plus 125 equals 24y. And now I'm going to move the 24y to the left side of the equation and move the minus 125 to the right side of the equation because I want it in standard format. Standard format is where you have the x's and the y's on one side and the number on the other, like that. So that's my new equation 1. You see how I got that?
Negative 25x minus 20.
I
So why is negative 125
from both sides. And I
okay.
subtracted 125 from both sides.
Okay.
Okay. So now I'm dealing with this equation 2 and this equation 1. And remember, my goal is to be able to eliminate a variable. Well, what if I take this equation 2 and I multiply both sides by 5? What am I going to get? I'm going to get 25x minus 25y equals, what's that, minus 120? So all I did was multiply this equation by 5, both sides. And now I have a new equation 1 and a new equation 2. But the beauty of my new equations, remember they're the same as the originals, I've just manipulated them a little bit, is now I can add these two equations and a variable goes away. The x gets eliminated. And I end up with minus 49y equals minus 245. Notice now I have one variable and I can solve for it. One variable in one equation you can always solve for. So y equals 245 divided by 49. Is that a... Yeah, exactly 5. Yeah.
No, 5.
And it's plus 5 because it was minus 245 divided by minus 49. Minus divided by minus is plus. So we've solved for one variable, y. And now you always have to go back and solve for the other variable. And the easiest way to do it is to choose amongst all of the equations I have written here, choose the simplest one. Well, to me, the simplest one is this one here because the numbers are the smallest. Okay. And I'm going to substitute y equal 5 for that. So I have 5x minus 5 times 5 equals minus 24. If I solve this equation, I have 5x minus 25 equals 24. And now I have 5x equals 1. So x equals 1/5. In other words, once you solve for one variable, you're home free. You can always solve for the other variable because now you're only looking at one equation and one unknown. So the key to doing these by elimination is to solve for one variable by eliminating the other one, and then go back and solve for the other variable, the one you eliminated.
Okay, so solve for one variable, get that answer, and then plug in what I got from the previous value?
Yes, exactly. In other words, we solved, you gave me two equations and two unknowns, and I was able to solve for one variable. I got y equal 5. Once I solved for that, I was able to go back into that relatively simple equation, substitute 5 for y, and solve for x.
Okay.
Okay?
Now, I understand how to do it. What I have a problem with is starting off. Like the first problem we had 3x, and you automatically knew that you was going to use negative 3x.
Yeah.
Like I get confused. How do I know what to multiply by?
Think about what your goal is. Your goal is to eliminate a variable. Let me give you another example here, and we'll see if you can figure it out. There's one equation. There's a second equation. They are not the same equation. Notice that the second equation is not just a multiple of the first equation. It's a different equation altogether. Now, given the fact that I want to be able to either add or subtract these two equations, what can I do to the first equation such that I will be able to eliminate a variable?
Multiply negative 2 on both sides?
Well, how about multiplying by positive 2? In other words, it's easier to add than it is subtract, right?
You said that earlier, yeah.
Everybody, it's easier to add than subtract, no matter who you are. I frequently tell people to always turn your subtraction problems into addition problems. But if I multiply the equation 1 both sides by 2, then you can always do that. You can always do anything you want to one side of an equation as long as you do it to another. Well, that produces positive 2x plus positive 2y equals 20. That's my new equation 1.
Okay.
Now, I'm going to add these two equations together. My new equation 1 with my old equation 2. I'm going to just add them together. Notice the very first thing that happens is the x's go away.
Yeah, they're going to cancel out.
Well, and that's what you're looking for. The reason this is called elimination is because you're trying to eliminate a variable. And what I end up with when I add the y's is I get a minus 3y equals 40. Well, now I can solve that for y. Once I come up with an answer for y, I can go back into either of these three equations that you see and solve for x. So the key with all of these problems is eliminate a variable, whatever you have to do to eliminate a variable, and that allows you to solve for the other variable. And then once you solve for the other variable, you can go back in and solve for the first variable that you eliminated. Because you only eliminated it when you added them together. You didn't change the original equation. I still have x plus y equals 10. So whatever I get for y, it'll be relatively easy to solve for x once I come up with one of the variables. Now let me just say one more thing. My first session for free is just a half an hour, and we're just about at the half-hour point. But let me do one more problem here, just to show you sometimes what you have to do. Let's say I have this one. Well, let me put a minus sign in front of that. Again, it's important to recognize that these two equations are completely different. One is not just a multiple of the other. That's the key. But also notice that there's no way I can add these things together or subtract them and have a variable get eliminated. And that's the key. We want to eliminate a variable. Well, what can I do? I could multiply the top equation by 5 and the bottom equation by 2. What happens if I do that? I multiply the top equation by 5, which is to say I'm going to do this, and I'm going to multiply the bottom equation by 2. Remember, I can do anything I want as long as I do it to both sides. Well, now equation number 1 reads like this: 10x plus 15y equals 50. And the new equation number 2 reads minus 10x plus 4y equals 50. And now these are my new equations, and notice that by merely adding these two equations together, x goes away. It gets eliminated. Even though it took me finding kind of a common denominator, similar process as finding a common denominator, but now notice that I can easily add the two equations. If I can, I don't know what's happened to my cursor here, but if I add those two equations, I get 0x 19y equals 100. Well, if 19y equals 100, I can solve for y. Once I've solved for y, now it's really a simple process to solve for x, because I can go back into any of the 4 equations, and I'm always going to choose the equation that has the smallest number. I'm going to take this top equation, 2x plus 3y equals 10. And I'm going to use that to solve for x, because it's the simplest. It's going to have the fewest. Whenever you have a choice of dealing with big numbers or small numbers, always choose small numbers if it's the same. In other words, my bottom equation, 2, is the same as my top equation, 2. It's just got bigger numbers. Everything's multiplied by 2. So if I'm trying to solve for the other variable, I need to go back into any of these 4 equations, but I'm going to choose the simplest one to solve for the other variable. And that's pretty much what we're going to do on any system of 2 equations and 2 variables. Okay. Ashley, I am going to, would you like to give me your email address, or did you put it in when you?
Yeah, I did.
Okay. I will send you a link tomorrow morning after your file is processed that is a recording of this file, and it essentially allows you to replay it in a YouTube format and hear all of the audio and see our common screen here. In other words, you can review every aspect of our tutoring session. And then you can decide to go from there. And if you'd like more tutoring, I'd be happy to help you. Just go to my website, Digital Math Tutor, and go to the PayPal option and make a payment. If you want a half-hour session, it's $16. If you want an hour session, it's $32. And you're welcome to schedule whenever I have an opening.
All right. Thank you so much.
You're welcome, Ashley. Nice talking to you and meeting you, and good luck to you.
Thank you.
Bye-bye.